Along with its toll on lives, livelihoods, and the state's infrastructure, flooding has always been one of California's costliest natural disasters. To protect people, property, and businesses from being victims of seasonal high water, Californians began developing flood control systems in the late 1800s, and improvements continue today. A combination of levees, weirs, bypasses, and reservoirs greatly reduce the public's fear of flooding, but not the risk and the danger. California's flood control systems are still vulnerable to an exceptionally severe storm. When we inventory the cities, homes, and industries that are present in the floodplain, it's obvious that flood-fighting personnel need to be ready. That's why flood fighters are trained each year to perform high-water heroics prior to flood emergencies. And the supplies they will need to do their job, sandbags, plastic sheeting, twine, stakes, tools, and all other flood-fighting materials are standing ready for flood emergencies in locations throughout California. During flood emergencies and periods of high water, critical levees and other structures are patrolled to spot any early warning signs. When a problem is found, flood fighters go to work performing tried and true methods that can prevent disaster. And although flood fight structures are temporary fixes, they must perform like permanent ones. So it's important that the work be done right the first time, because there may not be a second chance. The methods demonstrated in this video have proven to be extremely effective when coupled with a coordinated team response and the appropriate flood fighting materials. We will begin with the most important component of a flood fight, the filling and placement of sandbags. The goal is to fill and place them quickly and correctly. Working in pairs, one person holds the sandbag open while the other shovels sand. Holding the bags in a comfortable position reduces fatigue. As a bag is readied, the open edge of the bag is folded back, forming a collar to help grasp the bag and protect fingers. A shovelful of sand is placed on the lip of the bag to hold it open. Only fill the bags 1/3 full. This will help prevent back injuries when the bags are passed, carried, and placed. When passing sandbags, form a staggered line and stay close to each other to avoid injuries. Essential in building a strong sandbag structure is the positioning of the sandbags. When a bag is laid in position, the corner of the mouth of the bag is folded over, away from the flow or source of water. The next bag is then placed over the fold, with its corner folded over as well. This continues with each bag in the row. As additional rows are laid, all joints in neighboring bags are overlapped at least 1/3 of a bag, very much like a mason overlaps joints when building a brick wall. The bags are continually stomped into place to ensure a good seal with the ground and between the bags. With this simple sandbag positioning technique, we will show you how to build sack topping, diversion walls, boil sack rings, structure protection, wave wash protection, a raincoat, and an emergency spillway. Sack topping. Sack topping is used to raise low areas on the levee crown or creek embankment above a forecasted flood elevation. Rows of sandbags are positioned parallel to the flow of water. These are referred to as stretcher rows. The width of rows in the base layer is laid 1.5 times wider than the estimated height of the topping. This is usually achieved by placing one less row of bags with each additional layer. For example, if 3 rows are placed in the base layer, the next layer will have 2, and then a centered row on top. When completed, a cross-section view of the structure would be in the shape of a pyramid, with all joints overlapping. In most cases, stretcher rows can be used to build the entire sack-topping wall. However, when more strength is required, each additional layer can be placed in the opposite direction, across the previous layer. These are called cross rows. The diversion wall. A half-pyramid-shaped sandbag wall can be used for diverting water and mud flows. The tall side of the wall faces the flow of water and mud. As with most sandbag structures, the width of the base layer is 1.5 times wider than the estimated height of the structure. In this method, the second layer is placed directly over the bottom layer to begin forming the wall. Each joint is overlapped and stomped into place. Additional layers continue to be positioned, forming the shape of a half pyramid. The Boyle sack ring. When using sandbags to construct a sack ring around a levee boil, it's helpful to understand what's happening inside the levee's interior. A boil is the result of water piping through or under a levee and possibly eroding and enlarging the path of the flowing water. As water erodes the levee interior, the pace accelerates, carrying even more material with it. Without treatment or relaxation of floodwaters, the levee could eventually collapse and fail. To help prevent the levee from failing, a sack ring is built around the boil. As water fills the ring, the flow of water piping through the levee will slow down. The goal is to reduce the speed of the water so it no longer carries levee material. The flow of water is not stopped completely. This would cause renewed pressure within the levee, and another boil would form nearby. To build a sack ring, the first bags are positioned around the boil on firm ground, approximately 36 inches in diameter, or larger if necessary. The corner of the mouth of each bag is folded over, and the next bag is positioned over the fold. The bags are then stomped into place to ensure a good seal with the ground and the bags. Additional rings are placed around the first one, making sure that all joints overlap. As with all sandbag structures, the base of the sack ring should be approximately 1.5 times wider than its height. As the ring grows taller, the pool that forms in the sack ring will decrease the flow and speed of the water. When the water runs clear, a spillway is inserted. The spillway carries the flow of water away from the levee and stops pressure from increasing in the sack ring. This will help prevent additional boils from forming nearby. The spillway can be a length of PVC pipe, a double row of sandbags, or even 2 boards nailed together to form a trough. If a boil is located on the levee slope, a U-shaped sack ring can be built. If several boils are found close to each other, one sack ring can be built to surround all of them. Structure protection. Sandbag construction is also used to protect homes and buildings from rising floodwaters. First, doors, vents, and basement windows are covered with plywood. Then, a solid piece of 10 mil plastic is laid on the ground and up the wall of the structure, at least 1 foot above the projected height of the bags. The width will be 1.5 times the planned height of the sandbag protection. The first row of bags is placed on the plastic against the structure. The placement is similar to the diversion wall, with the additional layers facing the structure. Again, each joint is overlapped and stomped into place. Wave wash protection. During periods of strong winds and high water, wind-driven waves can scour and erode a levee or embankment. This is referred to as wave wash.
Using a combination of plastic sheeting, sandbags, and other materials can minimize wave wash. Plastic sheeting comes in rolls that are 10 feet by 20 feet by 10 mil. Other sizes and thicknesses are not recommended.
Beginning at the upend stream of the area to be protected, 2-foot 1 by 3 inch wooden stakes are driven into the ground along the levee shoulder. The stakes are spaced 4 feet apart, with every other stake staggered 1 foot to avoid weakening the levee. Below the stakes, the plastic sheeting is rolled out just above the area being protected. Several flood fighters hold the 2 edges of the plastic and shake it out to create a 10-foot deep envelope. Position the envelope's open edges so they face the top of the levee. The flood fight crew stands on one edge of the plastic and opens the envelope. Knotted sandbags are thrown inside to the bottom of the plastic, about 1 foot apart. The knotted bags are 1/3 full and can be easily tied by holding one of the corners and spinning the bag. Once the tied bags are positioned in the envelope, tie-down buttons are fastened through both layers of the plastic. Then baling twine is used to secure them to the stakes. If tie-down buttons are not available, a stone can be used to anchor the twine to the plastic. Next, a method forming a crisscross design of twine and sandbags adds additional weight to hold the plastic down. Starting on the upstream end of the protection, the twine is tied to the first stake. A knotted bag is suspended down to the middle of the plastic using a half-hitch loop positioned below the knot. The twine is not cut. A stake is skipped and the twine is tied to the next stake using another half-hitch. The half-hitch knot is helpful in making any needed adjustments. The next bag is positioned and adjusted so it hangs to the center of the plastic below the stake that was skipped. When 2 to 3 hanging bags have been placed, the same procedure can be started on the second upstream stake. As with the first stake, knotted bags are suspended down to the middle of the plastic. To extend the wave wash protection, another envelope is inserted at least 4 feet inside the previous envelope. To create the splice, 4 tie-down buttons are used to fasten the plastic to the stakes. 2 buttons secure the bottom 2 layers, and 2 buttons secure the top 2 layers, 4 feet apart. To complete the splice, sandbags are placed along the seam. If the slope is steep, some bags may need to be tied to a stake to help anchor the row. All seams are then covered with sandbags. Pencil-sized holes are poked in the bottom of the envelope between the inside bags to allow trapped water to drain. If more than a 10-foot width of slope needs protection, another layer of plastic can be placed above the first one. The new layer should overlap the first layer by at least 2 feet. Then the same procedure is followed with plastic sheeting and sandbags tied to the existing stakes. Finally, all additional seams are covered with sandbags. The raincoat. Plastic sheeting and sandbags can also be used to prevent further saturation of a levee or hillside slope. Referred to as a raincoat, the plastic is fully extended to create a 100-foot by 20-foot covering. Sandbags are then laid around the perimeter of the plastic. Knotted sandbags are then positioned to hold down the center of the plastic. If the slope is steep, the crisscross method of stakes, twine, and tied sandbags can be used to weigh the plastic down. The bag should be staggered on the plastic for maximum benefit. The emergency spillway. When a river is rising fast, an emergency spillway can be applied to a low section of levee to control overtopping. This method will permit floodwater to cross over the levee at the spillway while maintaining the levee's structural integrity. Avoiding uncontrolled overtopping should always be the #1 priority. In this method, a roll of plastic sheeting is fully extended over the levee crown and down its landside slope. Sandbags are then placed around all edges of the plastic. If needed, some of the bags on the slope can be tied to a stake to help anchor the row. As you observe flood fighting methods being performed, you can see that it's a strenuous, demanding job that relies heavily on teamwork and proper training. When you practice and perform these techniques, pay close attention to the personal safety of yourself and others. By doing so, your team can be more effective in helping to protect people, property, and businesses from being victims of flooding. For more information on flood fight methods and training, contact the California Department of Water Resources or your local flood control agencies.